All right, in this video, we're going to talk about the phase shift. And the phase shift is basically how much the graph of the sinusoidal function has been moved horizontally to the left or to the right. Okay, and so if you have, excuse me, if you have the graph of or the formula right in the format that we've been talking about, y equals a sine bx minus c plus d, or y equals a cosine of bx minus c plus d, then the phase shift is going to be c over b. So this one is probably the trickiest one for people to get because of the fact that it has to be written exactly in this format. It has to be written exactly as some number b times x minus some number c in order for this formula to work. All right, and that is tricky, okay, for some people to get at this level. So another thing is, again, if you are looking at another source, they might have their sinusoidal functions be in the format a sine bx plus c. Okay, in which case this formula is going to have a little minus sign out in front of it. So you've got to be careful about that. Another thing that kind of complicates things a little bit is that the phase shift is not unique. You can have different phase shifts for the same function. So all those things kind of work together to make it a little bit complicated. So to me, when I'm working through problems like this, what I like to do is to find the phase shift is just tell people, hey, just take the inside part of the trig function, bx minus c in this case, and set it equal to 0 and solve. That way you don't have to worry about, hey, is this in the exact format that I need or not, okay? It doesn't matter if you use this technique, okay? If you're just memorizing this formula here, then then you're going to have to make this match exactly if you're using this formula or any other one that anybody else gives from another source. Okay, so that's why I like just to work it through by setting the inside part and equal to 0 and solving that out. All right. Okay, so you can see when I start varying that value c, you can see it just starts sliding the graph horizontally to the left or to the right. With the basic sine function, the phase shift is 0. So this is the basic sine function, right? The basic sine function, being this one, right? The number with the x is 1, and it's minus 0, right? So it would look like this. And so c over b would be 0 over 1, right? Which just comes out to be 0, okay? So the phase shift, right, what it's going to tell you is how far that has been shifted, the graph has been shifted to the left or to the right, okay, of the function. All right, let's take a look at some examples here. All right, so find the phase shift of the sinusoidal function, all right? And so what you're going to do is just take this inside part, pi x minus 2, and set it equal to 0, and then solve that out. So it'll be pi x equals 2. Let's turn these off. All right, so you would add 2 to both sides to get pi x equals 2, and then do x equals 2 over pi, right? You would divide both sides by pi, and here is the phase shift. In this case, it's 0.636, okay? And so what that is, right, is the distance that that the function has been moved to the right or to the left, and from another version of it. So let me graph that out for you so you can see how that would go. So if I graph y equals minus 4 sine pi x minus 3, okay? And let me color it a different color because it's hard to tell the difference when they're both blue. So I'm going to color it orange. All right. And I'm going to turn this one off for a second. All right, and so the midline of this is y equals minus 3, right? Like so. Turn this off as well. All right, so here you can see the only difference between the original graph, right, and this one is that I removed that minus 2, okay? So the phase shift, right, would be 0 on this one, right, because the c is 0. And you can see that this is a sine function, right, that crosses the, here's the midline is right here at -3. And so you can see starting at 0 at the midline, this thing goes down. It goes down, right, because the number out in front is a negative number, right? And it's a sine, so it starts at 0 and goes down, right? At the midline it goes down. And so when I add that 2 in, what ends up happening is that the graph gets shifted to the right, okay? So you can see, even though I know it's kind of crowded, if I look at this point right here, right, this starting point, this midpoint where it was at the midline and going down on the orange graph, that's the one with phase shift 0. What's ended up happening is that that point has been moved out over here on the blue graph. So by adding that minus 2 in on the inside, it shifted the graph 0.637 units to the right. And you can see that's what the phase shift is right here. So that starting point, so to speak, has been shifted this distance to the right. Okay. All right, so next one. Let's turn this off. All right, so this one, the phase shift, to figure out what the phase shift on number 2 is, what I'm going to do, again, is use that trick I told you about. Take the inside part, set it equal to 0. All right, and then solve that equation. So I'm going to solve that equation. First thing I'm going to do is add 5 pi over 6 to both sides. So I get pi over 2 x equals 5 pi over 6, right, by adding 5 pi over 6 to both sides. And then to get x by itself, I am going to multiply both sides by 2 over pi. Like so, okay? Then over on this side, when I multiply that, I'm going to get 2 pi over 2 pi. Well, 2 pi over 2 pi is just equal to 1. So on this side, I'll get x. On this side, I'll get, over here, you can see I have a common factor. So of 2, 2 goes into itself once, and it goes into 6 3 times. So I get 5 pi or 5 over 3 pi. I also have a common factor of pi. Pi goes into itself once. It goes into pi once as well. So basically they cancel each other out, and I get 5 thirds. Okay. So the phase shift is 5 thirds. I turned off the graph of the original. Let's go back. Okay. So again, just to illustrate what that is, if I take this sinusoidal function and I get rid of the C, make it 0, you can see I get this blue graph right here. And the blue graph, remember the midline is 2 on this one. So if I look just at the blue graph, this is a cosine function, right? And so therefore it's going to start at the maximum point at 0 if it hasn't been shifted, right? The basic cosine function will start at a high point at 0, like this one does. All right, and so this graph that we're looking at, 3 cosine pi over 2x minus 5 pi over 6, is the graph of the blue graph shifted to the right this many units, right? Which is 5/3. All right, and you can see that's where that high point is on the shifted graph, 1.667. All right, so this is the value that has been, this is the value that the graph has been shifted over from sort of the basic graph where there's no shift at all, okay, where that C is 0. All right, so you can see it's not too difficult to find the phase shift if you follow that trick I showed you, right, which was take the inside part and set it equal to 0. And that's if you have, right, the formula. Finding it from the graph is more complicated, okay, but we'll work through an example of the Newton assignments, and you'll see the problems that you have to do there are not too bad, because if they ask you to find it from the graph, they pretty much tell you what it is by showing you, giving you some points on the graph, and you can just easily see what it is from the x coordinate. Like for instance, on this problem right here, they will give you this point, 1.667, and you can take that as the phase shift. So if you just remember that's the distance that first point has been shifted over to the left or to the right, then that's going to be the phase shift, finding it from the graph. In general, it's a little bit tricky to find it from the graph, especially if they don't give you a point, because it's not, the phase shift can be lots of different values, okay? And so that slightly makes it slightly more complicated. Okay, so again, right, the explanation of the phase shift, right? The phase shift is the amount that the graph is shifted horizontally, and the graph of a cosine bx minus c plus d, or a sine, it doesn't matter if it's sine or cosine, is the graph of the one where the c is 0, shifted horizontally, c over b units, okay? If the phase shift is positive, that means that it was shifted to the right, and if the phase shift comes out to be negative, that means that this graph was shifted to the left. Okay, and so I think that is it on the phase shift 1, and then we will work in the next video. We'll work some examples so you can get a feel for how the Newton problems work.